In this video we're going to be looking at the frustum of a cone and how to find its volume. So first of all, let's discuss what a frustum is. In geometry, a frustum is a portion of a solid, usually a cone or a pyramid, that remains after the top section has been chopped off. The frustum itself lies between two parallel faces. To calculate the volume of the frustum, in this case it's of the frustum of a cone, all we have to do is we find the volume of the whole cone, so imagine the top piece is still there. We find the volume of the piece that's been chopped off, and then we find the difference between the two of them. So in simple terms, the volume of the frustum is the volume of the big bit, take away the volume of the small bit. So here's an example of how we could calculate the volume of a frustum. Notice the information that's been given to us. We've been given a top radius, a bottom radius, and the distance between the two circular faces. So the first thing we've got to do is we need to use similarity to find the height of the smaller cone. And this follows on from a previous video. So the first step, draw out two diagrams representing the triangles that are inside the cone. So imagine we slice the cone into right down the middle. So we've got two triangles and we've got the various bits of information given to us. So we know the radius of each of the two circles. We find corresponding sides, which are highlighted in different colours here, and from that we can deduce what the scale factor of enlargement is going to be. Now, following the process from the previous video on similarity, we're able to deduce what h is going to be because we know the scale factor and we know the corresponding sides. And now I know h is 3 and therefore h plus 6 will be 9. So I've got the two heights of the two cones. I've got all the information I need now to work out the two volumes. So the big volume we work out first, so a third pi r squared h, well we know r was 9 and we know the height is also 9 and we can calculate that volume. Notice I'm leaving it in terms of pi. Work out the small volume, again a third pi, this time it's 3 squared times 3. That gives us the small volume and therefore the difference between the two of them is going to be the volume of the frustum. And we can give our answer to whatever degree of accuracy we require to do so. Another example, slightly harder. This time we're not going to have a nice scale factor. So what I've done here is I'm just drawing in to make it so I can see that I've got the top cone and the full cone. Just makes it a little bit easier to visualise. Same as before, I'm going to draw out two diagrams representing the small cone and one representing the big cone. and identify corresponding sides. And then find the scale factor of enlargement between sides of the same colour. So my scale factor here this time is 7/3, and I'm going to leave this as a fraction. Just as we did before, we know that by similarity that h times 7/3 equals h plus 3. Slightly harder question this one is, and as we did previously on the previous video, we've got our fraction here, so the best thing to do first of all is multiply both sides by 3 here to get rid of the fraction. Expanding the brackets and solving to find what h is going to be. And once again, I'm going to leave this as a fraction. And h plus 3, again, leaving as a improper fraction. Much easier to work with improper fractions in this situation. So now we're going to work out the volumes. So the volume of a big cone, and again, using the information exactly as we had before. So I'm going to be using 21/4 in this scenario, stick it into my calculator and then get my answer in terms of pi. I'm going to work out the volume of the small cone. Same process, and again, get my answer exactly in terms of pi. And therefore, to find the volume of the frustum, find the difference between the two of them. And this one actually comes to be a nice answer, 79 pi, which I can give to whatever degree of accuracy the question is asking me for.